Hi everyone. Today we are having a course on R programming language, which is Introduction to Interactive Visualizations using Shiny apps. And today we are joined by Diego Kozlowski, who is a researcher at School of Library and Information Science of the University of Montreal, and also Carolina Pradier, who is a PhD student in information science at UDEM. Thank you for being here. Welcome to Yo Sigo Publicando courses. And okay, we are ready to start whenever you are.
Okay, thank you very much, and thanks everybody for being here today. So as Victoria said, we will start working on development of apps in using R. I don't know whether you have any experience using R already, I hope so. So usually when we work with R or with any programming language, we use imperative programming, which means that we ask for the program to do something and the program immediately does this, or like responds to our instructions. For instance, we may ask for R to import a data set or apply a transformation, and the objects in our environment evolve as we ask for different services. So to develop apps, we will change completely the logic we will be using, and we will switch to what is called reactive programming, which is a way of writing code where we will write the commands that R has to resolve as functions of what the user will input. So when we design a Shiny app in R, we will basically have to design two main components. On one hand, we will have the user interface that will determine how our app looks. This will include both the widgets where the user will place the input and also the output that the user will receive. And on the other hand, we will have to design the server, which will define how the app actually works. What the server will do is to receive the inputs from the user interface and using them for the instructions that we tell the software to use, generate the outputs. So users will be manipulating the user interface. This will send inputs to the server, and the server will create the outputs and feed them back to the user. And a very, very important aspect of the development of apps is that we will have to join the inputs, the outputs, and the instructions in the server through unique corresponding IDs. We will get into this later in more depth, but the important thing here is that we will always refer to the same elements using the same IDs, and if these IDs are wrong, our app will completely stop working. So this will be a very important aspect of our Shiny app development. So the main package we will be using to develop apps is the Shiny package. And this little code snippet here is the basic structure of any Shiny app. So we will have to summon the library package, the Shiny package. Afterwards, we will have to define the user interface object. Afterwards, we will define the server object. And finally, we will bind both of them together to make the app run. So let's get into each of these elements in more detail. The user interface, as I said, will include everything the user will see: inputs, outputs, and layout functions. This is an example of what a user interface code might look like, which you will study with Diego in more depth in the practical part of the class. But basically, we have to first define some sort of layout. There are general layout functions such as fluid page that will give us a general framework of how our app will look. And then, as you can see in this little image, we can add different panels, like a title panel or a sidebar panel with the inputs or a main panel with the outputs. And Shiny comes with a lot of predefined layout functions, but considering that the user interface is an HTML document, it is possible to write using HTML language and customize the user interface. And on the other hand, we will have many different themes we can use to change the general aspect of the app, such as the font or the color of the background, this sort of things. And so once we have this general layout set up, we can define different input and output widgets. So there will be different kinds of inputs according to the kind of input we expect the user to give us. For example, numeric input is an input widget to obtain a number, text input is a widget to obtain text, etc. And each one of them will have, as I said, two core parameters. The first one is the input ID, which is the ID we will later use to refer to the user's input when we work with it in the server. And on the other hand, we will have a label, which is what the user will see, like, please state your name or whatever. And on the other hand, we will have different kinds of outputs, which will also need to have an output ID defined and associated to them, which is what will bind these outputs to the server functions. And just a small recommendation here, when we create plots in Shiny, we very much recommend to create them with using the Plotly package, which is used to design interactive visualizations. On the other hand, we will have the server, which will rely on all of our inputs and outputs. And inside our server object, we will define all of the functions that create the outputs. So the server will be a function of the input and the output. And basically, we will define each output as something with these rendering functions. A very important thing is that we will have to have a correspondence between the rendering functions and the kind of outputs. So for instance, if we want to do a plot output, we will use the render plot function. And this is the same for tables, images, or anything we create. These render functions are the functions responsible for dynamically generating the outputs every time the input changes. And they will be triggered every time the input changes. And an important thing to consider here is that we might not want to update the contents of our output every single time any one of the input changes. We might want to update them only as a consequence of a certain action, such as pressing on an update button. And in this case, we will have the option of having our rendering functions inside other functions that will control how often we update the output contents. This is a little example with a plot, where basically we will define the plot as a reactive element, which will change only as a function of changes in a certain input, in this case an action button, and we will only render a new plot once we get the instruction to update our plot. This might be useful, for example, when the design of a plot depends on various inputs, and we might want the user to define all of these inputs before actually building the new plot, instead of changing the plot every time the user modifies a single variable. So this is the basic structure of a very simple app. We will have the input, the output, the user interface, the server, and we will bind them together using the Shiny App function to make the app work. But as we create more complex apps, we will want to take care of to create two big subjects. On the one hand, we will want most of our data pre-processing to be carried out outside the app in order to make the app faster and more efficient. So we will usually have a script where we will prepare the data our app will actually use. And on the other hand, as our apps get more and more complex, we will start having extremely complicated scripts, which are bound to create errors, especially because of what I said earlier about the importance of having unique IDs. And therefore, one of our solutions to this problem is to create modules for each part of the app. For example, an app with many tabs might have a different module for the design of each of these tabs. And basically, the idea behind these modules is that we will create a namespace, and inside each of these namespaces is where the IDs will need to be unique. But IDs won't need to be globally unique for the whole app. And this way we can compartmentalize our code and work on each of these modules without affecting all of the app. And basically, if we design our apps using modules, we will then call our modules like this inside the user interface object and inside the server object. And we will just need to define IDs that join each module's user interface and server. Basically, when this would be like the basic directory structure when we work with modules. When we design a complex app, we'll have the app.r script where we will put together all the modules and make the app actually run. We'll have a script where we prepare our data, and then we will have a folder with the code designing each of the modules. Back to any app, not just extremely complex apps designed with modules. We will want to share our Shiny apps. These are two of the main scenarios where we might want to share our apps. They might be supporting materials to a paper or any sort of research or work. We might want to share our apps to increase reader engagement, to allow readers to analyze data independently. And on the other hand, we might want to use Shiny apps to share partial results with a team when developing a project. For example, when exploring a data set, we might want to show different sorts of visualizations using different variables, different parameters, and in this way define the best way to carry out a research project. So as you might see, these two reasons for sharing an app are very different. In the first case, we might want to reach a a large audience and make our app public. In the second case, we will be sharing our app with a reduced number of people, and we will probably want our results to be private. So there are two main ways to can either use a Shiny server. This is a better solution when we want to reach a big audience. A Shiny server is a complex server to set up, but once we set it up, we can host our apps within our organizations at a web address and use our app as much as we like. There is no limit to how many times or how many users can use our app. And the second option is publishing our app in shinyapps.io. This is much easier. You just have to press a button once you have a user at the site. But the free version of the apps hosted at shinyapps.io has a lot of limitations, such as the number of apps that can be hosted, the activity of the app, the number of users, etc. So for small projects or private projects, this is fine. But when we want to engage with a larger audience, we will need to learn how to use a server. And finally, before we start actually working on designing our app, we wanted to talk a little about the social role of Shiny Apps. We believe Shiny Apps are great, helping us in the task of democratizing data analysis and fostering the participation of the general public in scientific research. As I said earlier, we consider it as very important to allow users to independently explore the data instead of just receiving the results we consider most relevant. And in this way, we can really make data open. Because it's not just relevant to make raw data available to everybody, but we consider it is also very important to make the tools necessary to actually analyze and understand data available to everybody. And it is in this context that tools such as Shiny Apps can be extremely useful. So I think that's it. I don't know whether anybody has any questions or comments. Okay, so then Diego can start sharing his screen.
Okay, so the idea now is to make a few examples with some Shiny apps that, like very simple Shiny apps to see the step-by-step. But if anyone has a more conceptual question, maybe about the general functioning of apps or why we would like to use a Shiny app, etc., go ahead. It will be a good moment to do that. Otherwise, let me go for my first screen. Okay. So what I want to share. So we have, we are gonna share these materials later if you're interested, with the notes that Caro was using and also what I'm gonna use. And what we have here is basically a small project folder, and we are gonna create some Shiny apps inside of this, and I'm gonna follow this guided practice. So yeah, everybody can see this. So just to make a few examples, I'm not gonna be so organized in my exposition as Caro was. So just to show a few examples, if you go to Shiny, if you Google Shiny Gallery, you have a lot of examples of different Shiny apps and different types of widgets, and from the very simple Shiny that only has it's loading, that only has one figure and one input, and you can always see the code, to maybe more complex Shiny apps from users. So you can go to something like this with the map and the interactivity. So, and many different types of inputs. So basically, as Caro was saying before, the goal of a Shiny app is, so normally we talk a lot about open access in terms of open data, and to be able to access someone's research, the data that builds someone's research, to be able to reproduce it. But that's only one part of the story, because to be able to reproduce the analysis, you need the data, but you also need the knowledge on how to perform all those analyses. And if there are some statistical analysis involved, there is a burden. If there is a lot of coding involved, there is a burden. And we are not allowing people to access that type of research. So Shiny apps can help us in the sense of lowering that burden, because it people can engage with your research, people can engage with your analysis and try other alternatives, because normally when we do research, we are constraining our results to a really, really small subset of results, and probably we have to discard 90% of what we did in order to have like 5 figures in our paper. And Shiny apps can help us show all the other stuff and allow people to explore there. So, of course, we are going to constrain what people can see, because we have to do like the basics. Like the Shiny app will only show what we want to show, because it's only gonna show some figures, but we can include all these parameters that allow to make a larger exploration. So let me show, for example, oh, this is very chaotic. Sorry, Caro. She did the materials and did an amazing job in making everything really organized, and I'm gonna crash it. So let me see if I can find Shiny that I did. Let's see. Yeah. So let me see if I find my own paper. Probably not.
The link is in the materials. I can see.
The link of this paper? Amazing. And where? Like in the class notes?
I'll send it to you.
Thanks. Oh, you can put it on the
Yeah.
chat, actually. Thank you. Yeah. So, for example, I had this paper on a content analysis of some magazines from Argentina. I'm from Argentina, world champion. And we did some text analysis on the frequency of different keywords on men targeted and women targeted journals. And this was only like a few figures, because you cannot do this analysis for everything. So we had, let me show you, like for words related with family, business, children, fashion, or science, we had the relative frequency of those keywords in the different journals. But this is limited. It doesn't allow us to see the whole thing. Let me see if I can find. Okay, so what we did is to make a companion of our paper with a Shiny app. And in this Shiny app, it's in English, so I can go to English. We have the relative frequency for any word that we want to add that's in the vocabulary of this journal. So for example, if we select feminism related keywords, I can update, and this is what Caro was showing about the update button. And I can get my figure with the proportion of the relative frequency of these words in the men targeted and the women targeted journal, and we can see how the women-targeted journals started to talk about feminism way more than men, especially after 2015. But we can do that for, I don't know, abortion, for example. And if we look abortion, we see that it appears, and it allows for the endless exploration. So I have my own hypothesis in my paper, and I show the figures that I was interested about, but I cannot explore all the potential that this dataset has, because anyone can come and say, oh, and what happens with this other topic that's not abortion or feminism? What happens with, I don't know, whatever else? You can come here and look for those keywords. So of course it's constrained in the sense that I'm looking at the relative keywords in these two journals. So the research method is the same, is the one that we propose in the paper. But we can allow users to do this, and we publish the data, but only publishing the data doesn't allow a full exploration. If someone comes that's not from computer science or from like computational social science and doesn't know how to build a visualization, then they are not able to do this. But we provide the code that's on the back of this app, and together with the data, people can still explore. So we can engage people from more qualitative backgrounds in this type of analysis. So that's kind of the substance behind using Shiny apps for research. And what I want to show now is some small examples on how to build this. I'm gonna go step by step. So first, actually, let me crash everything again. And if we go, I hope everybody's familiar with the RStudio interface, but otherwise, you can always write on the chat. Caro will be also on the chat for help. You can also interrupt me, that's fine. So I'm gonna create a new, yes?
I have a question.
Yeah.
Would you mention this app in the paper?
Yes, of course.
Okay. I was thinking maybe it was too informal to do so, but...
I don't think it's informal. It's a companion, it's a website companion of the paper. And in my experience, I did this for a couple of papers, and it was always welcomed by the reviewers, by the editors. For a paper, one of the reviewers once said that our contribution was the Shiny app, and I was a bit offended by that because it's not the Shiny app, it's the whole other stuff. But so they normally have a very positive impact. And actually, if you look, some very important universities are developing, like they have their Shiny development group in the IT department. Like they have a sub-department for trying to get researchers to do this more often, because it's normally pretty useful for research.
Thank you. That's a great idea.
So what I'm gonna do now is to create a new Shiny app, and I want to do that from here so I'm using the folder structure here. I just created an empty folder, and if you put new Shiny web app, name is like some app, it creates this file. Okay, actually it created a new folder, which makes a lot of sense with the app inside. Why it makes a lot of sense? Because normally the app has to be named app.r in the traditional way. Like you can also have an app that's divided in server and user interface. We are not going to talk about that because that's like old school. You need to have an app.r, and when you have an app.r, RStudio is going to show you here the run app button. And it's also when you create a new Shiny app from here, from RStudio, instead of creating an empty file, it's already giving you a demo of a Shiny app. So if you just run, if you just run the app, it's already there. So we are gonna dismember this example and see the step-by-step of this. But this is the traditional example for Shiny apps. We have a widget here. We have the output of the figure here. We have a title here. And we have a two-side layout. We have the sidebar layout panel, and we have the main panel with our figure. So you can always start from scratch with this example and just rewrite everything from there. But we are gonna start from 0, so we can understand the different elements. So for example, if I remove all this, and I just keep the fluid page, and I remove everything on the server, so we have an empty user interface and an empty server, and let me also remove the comments. So we have like 3-liner, 4-liner with a shiny with a summon of the library. This still runs. This is an empty app. It exists, it works, but it's empty. What's happening here is that we are running only this line of code, and this line of code, it's a function that takes the user interface, takes the server, and puts everything together and make it run. And it's running on a port on the computer. So normally so this is a translation from R to web development. We are skipping all the noisy, all the complexity of web development, and we are using R because we are used to use, we know how to use R. If you have no experience in R or no interest in using R, maybe Shiny apps don't make sense, because this is the way R users create websites. But if you only wonder how to create a website, you want to do web development with JavaScript, HTML, and these other languages. R creates a translation between what we know, which is our software, and Shiny creates this, and the translation to HTML code and JavaScript that we don't have to look because it's ugly and it's hard. But it's creating, it always works in the same way. So if this is gonna run in a link in a computer, and this is the IP, and normally this is the IP of your local computer, and in a port, there's like web development stuff, doesn't matter. And we will have these 2 sections. But let me go to this. So what I'm gonna do now is I'm gonna copy the examples from this guided practice, but then we are gonna share the code, like all these materials, and you can also go line by line. So if we go one step further, what I'm adding here is a title panel. I'm adding this layout structure, as Caro was saying, and the server will still be empty. So when I run this, we got our title, we got a layout that we cannot fully see. We can see the great background of the sidebar layout, and here in this part there is a main layout that's empty, so we cannot see the difference between what I cannot put like this part here. But actually, if let me see some, I'm going crazy a bit. So actually what I'm doing here is an inspect element. You can do this on any website. So let me just randomly, I don't know, GitHub. If you go and double click and put inspect, you can always see the structure of your HTML. So you can, you can go like this, and you can see all the elements of the website, right? So, and this is really good for web scraping. So we can do the same for our app, and we can see the different elements in here. And if I point, we will have this part here. This is our sidebar layout, and then over here there's gonna be an empty main layout. And now we're gonna fill it with stuff. So the next step is to make a widget input. So what I'm adding here is a slider input, and this is a function that we use. So take a look at the structure of the code. We have this is what always needs to be there is this fluid page. And then we have a title panel, and then which is the first element of this fluid page. A second element, it's gonna always be separated by comma, and normally, like, one of the most common mistakes we are gonna do is to forget a comma, and this is not gonna work, and it's kind of a hard mistake to find. So be aware of that, and normally try to find the missing comma, the missing parentheses. That's always the case of problems with the user interface.
It's useful to indent our code to be able to identify those errors more easily.
Yeah, actually, if you select everything and do Command I, or I don't remember, you can see the shortcuts. There is a shortcut that will always indent. So if I do like this and I break the indentation, it's always fixing it. But if I remove the comma and okay, now it's showing me the problem, right? But sometimes if I don't know, if I add a parenthesis here that should not be there, and then well, this is a good example. I added this parenthesis. This is not gonna work, but the mistake is shown at the end. So that's also a typical problem that we have, because we are always gonna copy and paste our stuff. So if I copy and paste this, I have my second element and my third element, but if I copy and paste wrongly because I copy one extra parenthesis or whatever, there's where we create the problems. But going back to my point, we have an input widget, and this input widget will have some parameters. The most important one is the input ID, because as Caro was saying, this is the way the server over here and the user interface will communicate with each other through those IDs. And then each of those inputs will have different parameters. So actually, I think there is I need to keep my browser here. Widgets, Shiny Gallery. You can see all the different widgets that we have. So you can choose different options or select different stuff, or even upload a data, like a file. And you can always also see the code here. So if you do like this, you go to a second page, and so this is the output, this is the widget, and here is the user interface of your code. And we can see like checkbox group input is the specific widget in this case. So if you don't know how to add a different type of input, you can always come here and check the different options. And in this case, we are going to use a slider, and the slider needs to have, so we are going to move a point through a bar, and we are going to slide it. And it's going to have a minimum value, a maximum value, and we are going to assign that specific value. And we are always going to have a label. And let me show you what I'm talking about. I think that's easier. So we have number of beans as a label, and it's appearing here. So that's the instruction for the user of what to do with that input. And then we have a minimum value of 1, and we have a maximum value of 50. And then we have the one that says value is just the default value. So when you run the app, it's starting at that point. And then we also added here the plot output ID, and this and a specific ID. But this is not showing anything because there is no, so this is taking this output ID is trying to look in the server and trying to find this plot as a product of the server, and we are going to see how to do it later. But for now, the server is empty, so it's just not showing anything. So let's go and do that. And let me copy this next example. So now we keep the user interface as it was, and we start to add stuff on the server side. So you will see that it's not the same. Maybe I can do like this, and no. Maybe I can increase a bit the size. So we have these beans as an input ID, and we can find that in the server in everything that's in input, and it's an element of the input. So the server is a function. It has input and output as main arguments, and those are going to be lists. And in R, we can fill a list, like we can put elements into a list in this way using the $sign. So we are going to assign here, we are creating the element dist plot in this output list, and we are going to add something there. And then there is another list that's called input that has also elements, but the elements of this input are the ones that are created on the user interface. So while on the user interface, we add the ID explicitly as a string, like here input ID equals beans as a string, in the server side, everything is going to be an element of input using the $sign. So here, this function is going to take the beans, which are coming from the user interface, and it's going to use that to create the output. And then it's going to put all that result, all this result inside the dist plot. And here we have, so let me just show you, just so we make it more clear. So now that we added this figure, if I move the slider to a different value, it's taking a different input, and it's using that different input as a different number here. It's reacting to what I'm doing, and it's creating a new output. And this new output is saved in this output dist plot, and this dist plot is then taken by the user interface as an output ID. So this is how the connections between server and user interface work. And I know it might be complicated the first time. It can be confusing. So if anyone wants me to repeat in a different way, I can do that. But otherwise, I just want to show something related with outputs, that we always have this. So we are always working on these two sides. And for the user interface, we always need to wrap these outputs in some type of output function. In this case, it's a plot output function. And in the server side, we need to wrap everything within the render plot function. And if you see something weird here with the brackets, is because this is a reactive element. The brackets normally are used in R for reactivity. So this means that everything inside here needs to be reactive to a change somewhere. In this case, is a change in the beans. This means in the user interface. So this was the simple app. And I can go to a more shiny example, but I don't know if someone has a question or wants me to repeat something, maybe. This is like a quiet audience. I don't know if like everybody's following everything and this is boring, or nobody's following anything and this is boring.
Decíamos antes que si alguien quiere preguntar en español, no hay problema, a pesar de que todo el contenido esté en inglés.
Si no, I can move on to create something like this shiny app that we have here. So we will use this as an example and try to reproduce as something related with this. This is the Gapminder dataset. There is a package in R called Gapminder that has a sample of this, but otherwise the website Gapminder has a lot of information on socioeconomic indicators globally. So it's a really useful source, especially for these examples and visualizations. And let me copy the first example. So now we are loading way more packages because we are gonna use them in a more complex way. And the first thing I'm gonna do is to load that and to load Gapminder to the environment. So here we can see this is a sample of countries with their continent, the year of the collection of the data point, and information on the life expectancy, population, and GDP per capita of each country. And then we're going to do something weird, which is exclude Kuwait. And this is because we already did the exercise. We found that it's breaking the scale of the plots for some reasons. So we are just simplifying. You should not remove a country from your analysis just because it breaks the scale. That might be the interesting point of your analysis. But in this case, let's keep it simple. And then I'm going to start with this very, very simple layout with no elements inside. So this is going to be an empty shell. And what we want to do here is, so normally when you are developing your Shiny apps, you are not doing it in this way. You are just adding element by element, and you go to the server side, you go to the user interface, you do one figure, then you move to the next, and then you move to the next. In this case, because this is a pre-constructed example, we are creating the full layout of our Shiny app, and then we are going to include the different elements. But we wanted to introduce a different concept of the Shiny apps, which are the different tabs. So it's not necessary to have only one dashboard with the figures and the inputs. We can have many of them. So in this case, we are creating two main tabs, one for time series, and the other is going to be the distribution by year. And inside the time series, we are creating in the main panel, which is this thing here, we are creating two sub tabs, one for the plot and one for the table. And this panel here is going to have a shared sidebar layout. So we are going to normally put, and this is a tradition, but it's not mandatory, but commonly we put the inputs and the parameters for the user on the sidebar, and then we put the main results on the main panel, but you can always put everything wherever you want, actually, so you can be more creative. Actually, in this second layout, we are going to put the inputs on top and the results on the bottom. But the interesting part is that these two tabs are going to share the same parameters. And we do this with the, so we still have our sidebar layout, but now we also have this tab set panel. So every time you want to have multiple tabs, you need two elements. You need the tab set panel, and inside the tab set panel, you are going to add different tab panels. So here we have, actually, let me see if I can. There is something really cute about RStudio that you can use rainbow parentheses. So you have matching colors for the opening and closing parentheses, and this can be helpful. So now, for example, we have this tab panel here. All this is inside the first tab panel, which is the time series. And then we have a second tab panel. And normally we always miss this comma and we break things. Just be careful of that one. And this one is closing here. So we have one element, one tab panel here, a second tab panel here. Everything is inside the tab set panel. But actually, inside the first tab panel, we have a shared title, which is going to be the title of the tab. Let me show you again. So this time series title appears here. This distribution by year title appears here. And then we have inside this tab set panel, in the main panel, we have another tab set panel. And that's how we have the plots and we have the table. So we can always create these nested structures and make our Shiny apps as complex as we want. And we can have full websites extremely complex with many tabs working. This will have other challenges also, but we in principle can do that. And I'm gonna copy this example. I think we are already adding the functions. No, we are adding the different widgets. So I think I want to do this side by side thing. So now we have the code on the left and we have the Shiny on the right. So now we added the inputs. I added a selectize input, which allows me to find the countries, and we have all the different options of countries. So if we write something like we are suggested to add Argentina or Spain or whatever. And this is because it's the selectize type of widget. And we are giving this widget some choices, which are all the names of countries that appear here. And we are taking actually these names of countries from part of a small R code, which is taking the country column of this table and creating only the unique values, because otherwise they would be repeated and it doesn't make sense. And let me get back to my app. We are allowing for multiple options, but we can put false, and then we can only add one country at a time. And then, and we are naming this input as countries. So this is what the server is going to see when we say input $countries. And then we have another selectize input, which is not accepting multiple options. So it has a different look. And this is taking explicit list of explicit vector of values, which is life expectancy, POP, and GDP per capita. And it has the label of, okay, choose whatever column you want. But actually, let me do a change. You can use a named vector here. So if we put something like life expectancy, and then we put inflation equals blah, 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 and we put GDP per capita. If we run this, we can always try this. We can always run things just highlighting and command enter, and we get the result on the console. So here, instead of having just a vector, we have a named vector with the name life expectancy for the value life exp. And if I run this, now my options are more human readable, but the input that the server is going to take is the same value as before. So this still works for the server side selecting the right column, but we are mapping this with a more nicer names. So we have these options, and then we have in the main panel, we have for the other, here. And so here we have a title, time series plot, and then we have the table, and then it's going to have a plotly output that I'm not showing, and a data table output that I'm not showing because it's empty. And if I go to the distribution by year, we have another slider input, and actually we added here. So we are creating the parameters from the dataset itself. So this is actually useful when you are not sure which are the parameters you want, or you don't want to hard code stuff in your server, in your Shiny app. And we put animate true, so we can have this beautiful play button, and it's automatically moving in the different values. And we again have this plotly output. And this is something that Caro mentioned before. which is related with a different package that's not Shiny, that's Plotly. And let me go to the following example where I think we have, the functions, and I'm gonna show you the what Plotly is about. So this is the full app, and actually I can show you how it looks, and then with that teaser I can explain the step by step. So now we have our selection of countries, and I can put Argentina, and I can put Spain, and we can remove US. If you want some other country, you can let me know. And then we have this figure, but this figure is actually interactive, and it's showing us some labels with for that data point, the year, the value, the continent, and all this other information. And we can also change this is back to normal because I just copy and paste the other one. We can see the GDP per capita. We can see the population. We can see the different variables. And if we go to the table, we have this table for life expectancy. And if we sort it, we have Spain, etc. And then we have the distribution by year, which is not taking the first inputs. This is only taking this slider of the year. And if we press play, we can see how our figure is evolving over time. So this is a pretty cool Shiny app. It has also the information for each data point. So this is extremely useful when you're working with scatter plots, because then you're wondering who is this one, a big point on the extreme part of the distribution, and we can see that's US, and which is this other big point is China and India. So we can explore our data with much more detail, and this is something that we could never do with a static visualization, because if we have all the information of each point, then we cannot read the figure. So that's actually the magic of Plotly working there. So let me show you with this example. I'm gonna run on this. And we have now a function instead of our server. Then we are gonna see how this relates with Shiny. But first we have a function that's taking some input country and some input variable, and it's creating a figure. So let me see if I'm able to run this by hand. Actually, this might not work because this is designed to be used in the Shiny. So I don't know if I put Argentina, I might have a typo or I don't know, something, and it might not work. But let's see if I take this variable name here, life expectancy, then I have a figure on my R. So I have this interactive visualization. So what's happening here? This, instead of using a plot, actually, let me show you a difference. So what happens if I only show the plot? I run this again. I have a static visualization. This is the typical ggplot figure, and it's not doing anything special. And there is a one-liner that's pretty amazing, which is this function called ggplotly, which comes from the which comes from this package Plotly. Why it's saying America? Because if we look inside this function, this is taking the data gapminder. So let me actually do something. Countries, I'm gonna hard code stuff so we can explore. So if I take these values, now I can get inside the function because there is a value for countries and there is a value for bar. So I can get inside this and see what's happening. So let's run a line by line of this function. So what's gapminder? It's a data set, right? It has our columns, etc., etc. We are gonna first do a pivot longer to put all this information of life expectancy, population, and GDP per capita in a single column. So now we have a name and a value, and we have the value for each country in each year. We have the value for that specific variable. Why are we doing this? Because it's a small trick. Yeah, I was going to that, sorry. So we are gonna filter the countries in our input, and we are gonna filter the variables in our input. So now when I run this, I only have Argentina and life expectancy, and I have all the values, and the continent is Americas. But and then I'm gonna take this table and I'm gonna create a Shishi plot, a regular plain Shishi plot. It's gonna have here as the x-axis. It's gonna have the value in the y-axis, so this life expectancy. But this is pretty easy because now we always, yeah, it's just a trick to select the desired variable. We can do other tricks to do the same. And then for the color, we are using continent. And that's why it says Americas instead of Argentina, because we are not coloring by country, or coloring by continent. And this is like, if I do an example with many countries, then all the countries from the same continent are gonna look alike, and we won't do that. And group by country, so we have the line connecting the points of each country, a geom line and a geom point. This is our plain figure here. And then I take this element, which is a plot. It's not showing nothing different because I'm running the same thing once and over again. And when I run this with a ggplotly function, then this becomes interactive. And ggplotly is actually doing the same stuff that we are doing by hand with Shiny. It's taking our R code and it's translating our R code into JavaScript, HTML, and all these more low-level coding programs, languages that are used for web development. And it's helping us to avoid writing all these codes. If you have ever written a JavaScript figure like in D3, it's way more complex. So we are just skipping that complexity. So now we have our plot function that's going to take an input and it's going to create an output. And we are creating another function, basically the same. There are some tricks for ggplotly, but it's just another function. And we're going to use this in the server side. So now we have the same widgets as before. We have the selectize input for country, for the input variable. We have the time series, and we have this plotly output, because the plotly object is not the same as a PNG, as a static image from ggplot. So we need to use the right output function for the right type of element. So if we have a table, we have to use a table output. If we have a normal figure, we need to use the plot output. But if we have a plotly object, which is a different element, then actually, let me see if I can show you something. If I put this inside another element, we have the plot is a type of, we don't want to understand what's inside of this. This is a ggplot object. It's pretty complex, but we can see that the plot2, which is a plotly object, is very different inside. So it doesn't matter what's inside of here, but these are two different type of elements. So R needs to understand what is processing in order to give us the right output. So that's why we need a plotly output here, and then blah, 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 server. And on the server, we are gonna put everything inside our output list, and it's gonna be a parameter plot1, plot2. So this plot1 is the plot1 here. We already talked about this, but we need to use the correct render. If we are gonna work with a plotly, we need a render plotly instead of a render plot. And then we need the render data table. And the beautiful part of using the functions outside, first, is that you can test. And so developing this code is much more complex than our traditional R code, because the testing, if it's reactive code, is a bit more difficult, because we cannot go line by line to find our problems. But we can help ourselves by writing functions here instead of what we did for the other Shiny app, which had everything inside the server. Now we are taking things outside, and we can test this as we did before. We can test each of these functions if they work, if the input works as it's expected to, and it's creating the right output. Then we know that the problem is not inside this part of the code, and that's actually really helpful for debugging our problems. So we go to the server, and we only have a one-liner, and we know that what's inside of this, it's gonna work. And the only difference is that now we are using this function inside the server, and we are giving the parameters from the input list with the appropriate widgets. And we are rendering this with the render plotly, and we have these brackets here because it needs to be interactive. And we are doing the same for, so actually no, for the table, we didn't create a function, but we could. And we have the gapminder. We are filtering in the same way as we did before. We are selecting the correct column. So this is a different way to do this. And we could, yeah, it doesn't matter. There are many options to go to arrive to the same place. And then we have actually for the render data table, a lot of options for our table. I don't want to get into this detail. There is a lot of documentation, and it changes a lot depending on what you want to do. So maybe it would be boring to go into the detail. But if I look at the table, this is not a regular table. This is a table that can be sorted. And of course, it's not showing anything because there is only one country, but let's do it like this. So we can see different countries here, and actually we can export this to an Excel file, and I can export the table. And then we have the other function for the plotly here. So I think that's it for the practical part, and I was 10 minutes more than expected, so I can just finish now.
Thank you, Diego. No worries, we are still on time. If anyone has any questions, remember you can use the chat box or open your microphones. Also, talk in Spanish today. Quien quiera preguntar también en español, puede hacerlo, no hay problema. Well, I remind you, as always, that this course was recorded and is going to be available in our YouTube channel and also in our website related to this specific course page. And we can also add the materials Diego and Carolina were talking about, so that you can rewatch, rerun the code, and go through all the details. Okay, it seems everything was super clear, or maybe you need a bit more time to let the knowledge settle in. So thank you, Diego and Carolina, again, and I hope we can invite you again to Yo Sigo Publicando courses, maybe for another Shiny chapter or another art-related course. Okay, thank you, everyone.
Thank you.
When will the materials be available? Where? Sorry. I will post here our website, and you can look for the course there, and all the materials will be attached to the course, the specific course page. Okay. Thank you, everyone. See you next time.
Ciao, ciao.